I want to look at what happens when you have a function and its inverse function, and you do a composition of one inside of the other. The function and the inverse function, they cancel each other out. And it works the other way around as well. If you put the inverse function as the inside of the composition, the only thing that could possibly go wrong here is if you have some kind of domain issue. Here, by putting the exponential inside and the logarithmic outside, all we're getting is the y equals x function because everything canceled out. But then if we do it the other way around, then the x needs to go through the logarithm first. And that has a domain restriction which only allows for positive numbers. One example that doesn't have any problems is the x to the power of 3 and its inverse, the cubic root of x. You can put the cubic root inside or you can put the cubic root outside, and in both cases you just get as the composition the line y equals x. The purple function is just square root of x. You know that they're going to cancel out, but if the square root is inside, then the domain of that resulting composition is only going to be the positive numbers. However, when we use the x squared as the inside part of the composition, that doesn't have a domain restriction. So now it's not just a part of the y equals x line. But if you're putting a negative number in the x, then you're looking at the other side of the quadratic. You're not exactly looking at the reflection of the same thing because the square root is the reflection of this part, not of that part. Well, the sine inverse is the one that has the smaller domain. So if I put it as the inside of the composition, it's just a small part that matches the domain of the arcsine function, but the sine function has the domain that is all real numbers. So if we put that inside of the composition and the other one outside, it's not going to restrict the domain. It doesn't cancel out properly. And that is what it looks like. It goes up and down and up and down. Because this function has infinitely many turning points, we have to split the domain in infinitely many intervals. A line with slope sometimes 1, sometimes -1, because in some of those intervals the function is increasing and in others it is decreasing. The arctangent function has a domain that is everybody. So when we put it as the inside function, I expect to see the y equals x line with no domain restriction. But when I put the tangent inside, it's going to be a little different because the domain of tangent does go all the way from -infinity to infinity, but it has all of these points along the way that are not included in the domain. The tangent function is always increasing. I am composing back with the inverse from a different interval, so it can't just cancel out. You get all of these points where the function breaks and stops and goes somewhere else.